Hello everyone. So today we'll solve the question reverse odd level of binary tree. Okay, this is a today's Leetcode daily challenge question. So the question is given the root of perfect binary tree and reverse the node values at each odd level of the tree. Okay, suppose the node values at level 3 are this, then we have to reverse. Okay, and we have to return the root of reverse tree, and a binary tree is a perfect if all the parent nodes have two children and all leaves are on the same level. Okay, so this is our perfect binary tree, and we have to reverse the node values at each odd level. So this is a 0 1 2, so this is our odd level. Okay, so here it is reverse, that is 5 3 5 to 5 3. Okay, if you see this example, 13 11 11 13. Okay, so we have to, okay, we are given a perfect binary tree. Okay. Then what next thing we have to do is we have to reverse the node values at odd level. So that means it is a zero level, one, two, three, four. So at level one, at level three. So we have to reverse the node values at odd level. Okay. So okay. How we will solve this question is, first thing, we can use like, if we think like naive approach, what will be the naive approach is we will create a new tree, or we will store these values in some data structure like linked list or array. We mostly linked list only, and then we will reverse the linked list and same again assign the values. Like for example, we are using the level order traversal, and in that we will get at each level the values. Okay, and in the first level order traversal, we will collect the values and store in some list. And again, we will use the level order traversal. Again, we will apply on the same tree. And at that time, what we will do, we will reverse it. That means we already have the value. So, in the first traversal, I got this 3 and 5. In the second traversal, I will assign this node as a 5 and for this as a 3. Okay, I'll reverse the linked list and I'll assign the values. So this will be the first approach, or the naive approach, you can say. But here we like, even the our time complexity and space complexity, as we are using another data structure to store the values again. Okay, so it will like this will be a naive approach. So we will see how we can go to the next level of, like, how we will think for optimal approach. Then, okay, what we have to do, we have to reverse. So while reversing, for example, we want to reverse a array. Okay, so in that case, what is the approach you use? Like for optimal solution, we will swap, right? We use the two pointers. One is at the start, one is at the end of array, and then we will swap the first start and end. Again, we'll increment the start, and we'll decrement the end, and again we'll swap this till when, till it reach the midpoint. Okay. So similarly, can we use the same approach here? That if we have one pointer at this 3 and one pointer at my 5, then can we just swap these two numbers? We can, right? So let's say this is our this is at level 2, this is not an odd level. Okay, but still think like this is our odd level, so that we will use the same approach whatever we are thinking. Yeah, so let's say we have one pointer at 8 and one pointer at 34. Can we swap these two numbers, 34 and 8? And then I want my pointer to be at 21 and at 13, then swap these two. Is it possible? Right, so we can use this approach, that we will having two pointers at one will be on the left tree, okay, left subtree, and one will be on the right subtree. Okay, and we will just swap the node values. Okay, so in this case, which order we will be using? Let's say for left, which order we can use? Which traversal basically we can use? We can use the pre-order, and for the right we can use the post-order. So in the pre-order, how in a tree it traverses, first is left. Okay, in pre-order, how it is there, left, root, and right. First it will go to the left subtree, then root, then right. And in post order, how it is there, right, root, and left. Okay, consider this example, and I am applying pre-order on my left subtree, and I am applying post-order on my right subtree. So in that case, For now, just leave the odd level or even level. I will just dry run like how our approach will be working for this. Okay, so first it will go on this. This route, this node will be passing. Okay, left subtree, that means, and then left to it for pre-order. What will be the pre-order of this subtree? It will be 8, 3, and 13. Okay, it will be 8, 3, and 13. And for the post order on the right subtree, what will be the post order? 34, 5, and 21. 34, 5, and 21. Okay, so in pre order, we'll go like this, right? And for the post order, we'll go like this. So basically, we are moving one pointer at the start and one at the end. Okay, likewise, we used to do in array. So can we just swap 84 to 8, 34 to 8, that is 34 to 8, 5 to 3, 5 to 3, and again 21 to 31, 13, right? So we got this, we will be able to get that two numbers or the pairs which we want to swap. Okay, so this is just a normal way. Okay, for but what we want at odd level. So we will check if our level is odd or not. We will pass a we'll use one variable, okay, which will keep track of our level, and if it is a odd level, then only we'll swap. Okay, so let's start coding. I'll create a one method. It will do change value. Okay, and what we have to pass? We have to pass, as we want pre-order and post-order, we can use the same method to do this, because at the same time we want na, we don't want to store it and again replace it. Okay, at that time only, when our left node, okay, left pointer is at 3, at that time only our right pointer should be at 5. Okay, so we'll use I mean pre-order and post-order both will be at the same time. Okay, post-order. Now if pre-order is not equal to null and post-order is not equal to null, and okay, so whenever you are applying, or what I say, whenever you want a pre-order, okay, if I use this route, in that case I want, if I like I want a pre-order from this route for this tree, then what will be the result? 2, 3, 8, 13, and it will go like this. Then 5, 21, 34, right? But I want only this, so I will be passing what? I will be passing only the left tree, okay, and right tree. And I'll use one more condition. It both should not equal. Okay, that means anyway I'm passing its left and right, but still if we have a only like, if for the same route I don't want to do a swapping, right? So that is why I'm using this, because it has only one value. Then we have change value, we'll call the same. Then for pre-order, what we want, we want to call it for left, comma, for post order dot right. And again change value, pre-order dot right, comma, post order dot left. Okay, this is fine, because left root right, right root left. So in the root, instead of printing, okay, because we used to print while traversing, okay, here we want to swap, and for that we also want a level, so I'm passing here a level. Okay, and here we will pass level plus 1, a level plus 1, and here comma level plus 1. Okay, then now if my level percent 2 is not equal to 0, that means it is a odd level. If it is odd level, I want to do the swapping, and simple we can use a two variable, like we use a third variable for swapping. First pre-order dot val, then pre-order dot val equal to post order dot val, and post order dot val is equal to 10. Okay, then we swap, and then we'll call this method here, uh, change value. We'll pass root dot left, comma root dot right. Like we can pass root, because as we have used this condition anyway, it will not repeat, because when it comes at true, the thing is first time we are passing root, at that time we have to again use some flag that once on the, I mean, first time just ignore this condition, and from the next time, instead of that, I'm passing the root dot left and root dot right only, and my level will be 1. Okay, because I'm passing this node, right? So my level is 1. If I pass root, then my level will be 0. And then I'll return the root node, because we are making the changes in the same root or same tree. Let's run this. Yeah, you can say accepted. Let's submit. Yeah, you can see our solution got accepted, and with it beats the 100%. Okay, so in this way you can solve this question, and there are different ways of solving this question, but this was the optimized one, where we are just modifying the tree instead of creating a copy of tree, or storing the values and then assigning the values. So instead of that, at the time only we are swapping it. Okay, so if you feel this video is helpful to you, then please like this video, subscribe my channel, stay updated. Thank you so much for watching.